Assalamu alaikum. My name is Imad and I am from BSPT Batch 10 and my roll number is 6. Today I will be presenting my second presentation and the topic of my presentation is chemistry of other planets that are present in our solar system. So first of all comes cosmology and cosmochemistry. So cosmology is the scientific study of the large-scale properties of the universe as a whole. Like any field of science, cosmology involves the formation of theories or hypotheses about the universe which make specific predictions for phenomena that can be tested with observations. Cosmochemistry involves the study of chemical composition of matter which is present in the universe and the processes which led to those compositions. Sun. So Sun is the star at the center of the solar system. It is nearly perfect sphere of hot plasma heated by nuclear fusion reactions in its core, radiating the energy mainly as visible light and infrared radiations. It is foremost the most important source of energy for the life that is present on the Earth. So let's talk about the chemistry of Sun. So Sun mainly consists of hydrogen. There are about 67 chemical elements that are found in the Sun. Hydrogen is the most abundant element of all the elements. It is it accounts for 90% of the atoms and over 70% of the solar mass of the Sun. The second most abundant element that is present in the Sun is helium. It accounts for almost just under 9% of the atoms and about 27% of the mass. There are only uh, trace amounts of other elements that are present on Sun, which includes oxygen, carbon, nitrogen, silicon, magnesium, neon, iron, and sulfur. These trace elements make up less than 0.1% of the mass of the Sun. So Sun is constantly fusing hydrogen into helium. So that is why it is providing heat energy and light. So elements which are heavier than helium form in the Sun's core. They form in the convection zone, which is the outermost layer of the solar interior. Temperatures in this region are cool enough that the atoms there have enough energy to hold their electrons. This makes the convection zone darker or more opaque, which traps heat and cause plasma to appear and boil from convection. The motion carries heat to the bottom layer of the solar atmosphere and photosphere. Energy in photosphere is released as light, which travels through the solar atmosphere and passes into space. This light then reaches the Earth after 8 minutes as it leaves the Sun, because light also takes some time to travel in the space. So now comes the Mercury. So Mercury is the smallest planet in our solar system, and it is most closest to the Sun. Its orbit around the Sun takes 87.97 Earth days, which is shortest of all the Sun's planets. Astronomers believe that Mercury composition is made of approximately 70% of metals, and they believe that Mercury is a huge iron core, which makes most of its interior. The core nearly takes about three or four of the planet diameter. Mercury's iron core is about the nearly the size of the moon, which makes Mercury's most of the weight. And Mercury is also uh, believed to be the most iron-rich planet in our solar system. It's only slightly less than that of Earth. Mercury is believed to form about 4.5 billion years ago when gravity pulled swirling gas and dust together to form the smallest planet nearest to the Sun. Like its fellow terrestrial planets, Mercury has a central core, a rocky mantle, and a solid crust. Scientists have known for some time Mercury that it is rather strange. It is significantly smaller than the other planets that are close to it. It has an oversized molten core, which was formed under chemical conditions that determined it would contain much less oxidized material than the other rocky planets. Mercury is even believed to have ice deposits south near its north pole deposit. The fact that most of the surface is hot enough to melt lead, because there is virtually no atmosphere to speak of. Permanently shadowed areas can be cold as minus 170 degrees Celsius. Mercury does not have any atmosphere. Its gravity is about 38% that of Earth, which isn't capable of retaining much of the atmosphere. And in addition, its proximity to the sun is close, which means that the solar wind can carry gases away from the surface of the Mercury. Particles from solar wind, coupled with the vaporization of surface rock as a result of um, meteor impacts, are probably the largest contributors to the Mercury's atmosphere. So now comes Venus. So Venus is the second planet from the Sun. It is named after the Roman goddess of love and beauty. As the brightest natural object in Earth's night sky after the Moon, Venus can cast shadows and can be, on rare occasions, visible to the naked eye in broad light from from our Earth. So Venus is primarily composed of carbon dioxide, and which is much denser and hotter than that of Earth. The Venus atmosphere sports opaque clouds that are made up of sulfuric acid, making optical Earth-based and orbital observation of the surface impossible. So it means that we cannot observe Venus from our naked eye from the Earth. Aside from carbon dioxide, the other component that is found in Venus is nitrogen. Other chemical compounds are present only in very few amounts. The atmosphere in the state of vigorous circulation and superrotation. Unlike Earth, Venus lacks magnetic field. So Venus temperature is about 465 degrees hot, which is hot enough to melt lead. Many scientists believe water once existed on the surface of the Venus, but now there is no water present on the Venus, according to the astronomers. So Earth, which is our home planet. So Earth is the third planet from the Sun and only the astronomical object known to harbor and support life. About 29% of the Earth's surface is land, which consists of continents and different islands. Earth's interior includes uh, a thin layer which is around 5 to 70 kilometers thick of oceanic and con- continental crust, which is lying around 6,300 kilometers of rock and metals. The crust varies in thickness and density, with oceanic crust consisting of a thin layer of dense rock and continental crust consisting of less dense, lighter colored rock ranging between 30 kilometer and 70 kilometer in thickness. Although the crust is comprised of many types of rocks and it contains hundreds of different minerals, these materials are assembled from a very little number of elements, which include uh, 8 elements, which are oxygen, which consists around 46.6%, silicon, which is around 27.72%, aluminum, which is around 8.13%, and iron is 5%, calcium, which is around 3.63%, sodium, which is around 2.83%, and potassium and magnesium, which are around 2.70% and 2.09% relatively. These amounts form the building blocks of most of the inorganic materials we use in our daily life, such as glass, concrete, and iron. Oceanic crust is dominated by minerals consisting of silicon, oxygen, and magnesium. So this is the composition of Earth, which includes iron, oxygen, magnesium, silicon, sulfur, nickel, calcium, aluminium, and other elements. With iron taking the lead, and it make up around 35% of the Earth crust. I have described the elemental composition of the Earth previously, in which oxygen takes the lead and which is around 46.60%. So there is an envelope of gases that we call the Earth's atmosphere, and it is present in the gravity, which within 50 miles of the surface. So the air is thoroughly mixed with different variations of permanent and constituent gases. There are three main gases that are present on the Earth's surface, which are nitrogen, oxygen, and argon, which comprised around 99% of the dry air by volume. Water vapor is also present in variable amounts, and its presence can be about around 4%. So now comes the moon. So moon is made up of rock and mantle, just like the Earth and the rocky planets. The crust of the moon's outer shell is covered by lunar soil, also called regolith, regolith, which is a blanket of fine rock particles varying between 3 and 20 meters deep. Moon is similar to Earth in crust. So it contains mantle and core. The core of the moon is believed to be at least partly molten and probably consists of iron with some sulfur and nickel. The moon has thin atmosphere, so even footprint or dust can sit undistributed for centuries. Without much of an atmosphere, heat is not held near surface, so temperature vary widely. Day temperature on sunny side of the moon reaches around 134 degrees Celsius. On dark side, it is as cold as minus 153 degrees Celsius. So moon is made up of around 43% of oxygen. There is 20% of silicon, 19% magnesium, 10% iron, 3% calcium, 3% aluminium, 0.42% Cr, and 0.18% titanium, and 0.12% Mn. Now comes Mars. Mars consists of silicates, metals, and other elements, which are typically made up of rock. Mars is differentiated planet that the central core made up of metallic iron and nickel surrounded by less dense silicate mantle and crust. Mars is the fourth planet from the Sun and the second smallest planet in the solar system. It is only larger than that of Mercury. Mars, Mars is of red color and it is due to the oxidation of iron on its surface. Mars, uh, Mars, hydrogen is present as water, which is present in the form of ice and in hydrated minerals. Carbon occurs as carbon dioxide in the atmosphere of Mars, and it is as dry ice at the poles. An unknown amount of the carbon is also stored in the carbonates. Molecular nitrogen makes up around 2.7% of the atmosphere. As far as we know, organic compounds are absent except for a trace of methane detected in the atmosphere. So now comes the Jupiter. So Jupiter is the fifth and largest planet in our solar system. This gas giant has a thick atmosphere. Jupiter is mainly composed of different gases. This is a very large planet which radiates twice as much heat as it absorbs from the Sun. Jupiter's gaseous surface is very windy. The light-colored bands that can be seen through telescope from the Earth or the dark ones are called belts. The differences in the colors are caused by slight differences in the chemical composition and temperature, but the uh, main reasons are mostly unknown. The color of a region depends upon its altitude. Jupiter has faint, dark, narrow rings composed of tiny rocky fragments and dust, which is present around Jupiter. The atmosphere of Jupiter, uh, so Jupiter is a gaseous planet. It does not have a solid surface, just like the Earth and the other planets. When we look at Jupiter, we see ice clouds, which are made up of gases and they are moving at high speeds in the atmosphere. Jupiter atmosphere is mainly composed of 90% of hydrogen and 10% of helium. There are only little traces of methane and water, ammonia, and rock dust. Now comes the planet Saturn. Saturn is the sixth planet from the Sun in our solar system. So it is the largest second planet in our solar system. It has beautiful rings that are mainly made up of ice chunks that range in size and that can be nearly around the size of a fingernail and can be as large as the size of a car. So this planet is mainly most made up of hydrogen and helium gases, and is this planet is also visible without using a telescope. But low power telescope is needed to see its rings that are around it. So now comes the atmosphere. So Saturn is mainly made up of 97% of hydrogen gas, about 3% helium gas, and about 0.05% methane plus ammonia. The clouds in the atmosphere are cold, thick, and in uniform shape. Saturn is a gaseous planet with a rocky core, a liquid metallic hydrogen layer above the core, and a molecular hydrogen layer above that. The hot, heavy, rocky core has a radius possibly three times the radius of the Earth. So now comes the planet Titan. So Titan, so Titan is the biggest moon of the Saturn and the second largest moon in the solar system. It is mainly, it may rain liquid methane. It is larger than the planets Mercury and Pluto. Its atmosphere mostly have nitrogen with some amount of methane. Uranus. So Uranus is the seventh planet from the Sun in our solar system. This huge ice giant is covered with clouds and is encircled by a belt of 11 rings and 22 known moons. Uranus' blue color is caused by the methane in its atmosphere, and this molecule absorbs red lights. Uranus has a thick cloud cover, and its blue-green color is the result of the methane in its atmosphere. So, in the atmosphere of Uranus, it consists of 83% hydrogen, which is its main component, and 15% of helium and trace amounts of methane, which are around 2%. Its gravity is only 0.9% of that of Earth. Its air pressure is 1.3 times as Earth, and its temperature is nearly 2300 degrees Celsius. And Uranus has a rocky core, and the center of the Uranus may be around the size of that Earth. And and it is a fluid mix of water, methane, and ammonia ices. Uranus is a frozen gaseous planet. Its atmosphere is icy, and it has an icy cloud layer, which is made up of frozen methane, ethane, and acetylene, which circles around the planet uh, at the speed of 300 kilometers per hour. Uranus' icy atmosphere consists of 83% hydrogen, 15% helium, and 2% methane. So now comes Neptune. Neptune is the eighth planet from the Sun in our solar system. This is also a icy planet and is giant and has a hazy atmosphere, and it has strong winds that are blowing on it. It is orbited by 8 moons and narrow faint rings arranged in clumps. Neptune's blue color is caused by methane, just like Uranus, and these molecules absorb red lights. The core of the Neptune is made up of rock and ice. The atmosphere of Neptune has hydrogen, ethane, hydrogen, helium, and methane. 74% hydrogen is present, 25% helium, and methane is in trace amount, which is just around 1%. Neptune's atmosphere has icy clouds and enormous storms. These features change rapidly because of the tremendous winds that whip around the planet. Neptune has the fastest wind in our solar system. Icy particles of methane in the outer parts of its atmosphere give Neptune its deep blue color. Methane also absorbs red light. So now comes Pluto. Pluto is a dwarf planet that usually orbits past the orbit of Neptune. Pluto's composition is unknown, but it is supposed that it can be made up of 70% rock and 30% water. This is determined by the density calculations. Pluto's density is around 2000 kilogram per meter cube. There may be methane ice together with frozen nitrogen and carbon dioxide on the cold rocky surface. About atmosphere, it is not much known, but probably nitrogen is present in its atmosphere with a little carbon monoxide and methane. And life cannot be existed on the planet because of the atmosphere. The atmospheric pressure is also very low. The atmosphere forms when Pluto is closest to the sun, and the furthest methane is vaporized by solar heat when it is further from the sun. The methane freezes again from Pluto, the sky would appear black even when the sun is up. So now comes asteroids, which are widely present in our solar system. So these are uh, so these are com- com- so these asteroids composition is of silicate materials, iron and nickel, and carbon material. So meteoroids. Almost all meteoroids contains nickel and irons. They have three main classifications: iron, stone, and stony irons. Some stone meteoroids contain grain-like inclusions known as chondrules and are called chondroids. Comets. The nucleus is a relatively solid and stable centrally located pod, mostly formed of ice and gas with a small amount of dust under the solids like hydrocarbons. An interesting characteristic of the nucleus surface is the presence of dust. That was all, and thank you very much.